All right, we are live again. Welcome back. Everyone can see. As you can tell, lighting for live streams is not my forte. But in any case, today we're going to do the diving ketchup experiment. And what you'll need is a ketchup packet, like the little ones you'll get at a fast food joint. Maybe if you went to Kentucky Fried Chicken or Popeyes, or back where I'm from, Lee's Famous Recipe Chicken, and they give you some ketchup. You'll also need an empty plastic bottle. Again, 16 ounce, 20 ounce, even a 2 liter would work. Should be fine. It needs to be empty. Then you'll need some water. You're going to fill that bottle completely up with water. Okay, so again, we're doing the diving ketchup experiment. You're going to need a ketchup packet like this right here. All right, like a little ketchup packet. You'll need an empty plastic bottle, like what I have here. And then you'll need some water. All right. So we will get started in about a minute and a half, and let some people sign on, and we'll get going. So you got a couple people on. Good to see you. We'll get started here in just a moment. All right, we'll go ahead and get started. Welcome back. My name is Dr. Boyd, the chemist, if you're new here. And I am a research chemist. I work at the Naval Research Lab in Washington, D.C. I am teleworking, so I do this in my break time, and hopefully I'm helping. The experiments that we do and the lessons that we teach are geared towards children who are probably about 5 to 11 years old, like kindergarten age to about 5th grade. And I know that's a big, wide range. I get that. But I do hope that I'm able to at least benefit parents who have children in that age bracket. And hopefully the experiments are easy enough to follow for anyone who wants to follow along. And I understand sometimes we don't have all of the things that I'm using to bring the experiment to you, but most of the things I think you can find around the household. So I do hope that is the case. Today we're doing the diving ketchup experiment. You're going to need a ketchup packet. If you don't have a ketchup packet, any kind of little packet like this, for example, hot sauce from Taco Bell, or honey from the rolls that you get at Popeyes, or I'm trying to think what else. Soy sauce sometimes comes in little packets like these. Any kind of packet like this will work. I'm using ketchup, so I call it the diving ketchup experiment. And that's what you'll need. Just need one of them. You can use more than one. Maybe I'll try that too as we get going on this. You'll need a packet like that, a ketchup packet. You'll need an empty bottle, and you will absolutely need the cap for that bottle. Okay, you're going to need the cap in order for this to work today. And we're going to fill that bottle up with water as we get going. But as always, let's talk about what's most important. The most important thing to consider when I do an experiment of any type as a researcher is I must pay attention to safety. All right, safety is the most important thing for me to pay attention to whenever I do any kind of experiment, the first thing I'm concerned with is, as I write up my experiment, how can I execute it safely? How can I do it safely? All right. Why? The reason why is I don't want to harm myself and I don't want to harm the people around me. I also don't want to break equipment. I don't want to have to break. I don't want to break equipment because one, is expensive. At least the stuff I work with often is very, very, very expensive. Like some of the things I work with could be like this big. You could buy a whole house with it in terms of its dollar value. So I don't want to break anything like that. It's very expensive. But I also don't want to break it because that will set me back. That means I have to wait for it to get fixed or find somebody else with the same kind of equipment. So again, safety is important for lots of reasons. I don't want to harm myself or other people. I don't want to break the equipment. All right. Typical safety gear includes eye protection like safety glasses or goggles, gloves, and a lab coat. All right. The goggles protect my eyes, the gloves protect my hands, and then the lab coat will protect my body and my clothing. All right. And that is typical of the kind of what we call personal protective equipment or PPE that we wear, that I wear when I go into the lab. And I'm a chemist, so that means I do run reactions. And I actually do go into the laboratory and I run reactions. So you may have seen this depicted in movies or in cartoons. I'm that guy, the mad scientist. I do that. And it's fun. I really enjoy it. So safety is critically important. The other thing that's very important that I keep discussing, and I want to make it clear to you, I always take notes. I have notes. And actually, before I do these live streams, I have run the experiment at least once before I do it live with you all, and to make sure it works that day. Now, a lot of these things I've done many, many, many times, but sometimes things don't work like you think they should. So I try to run it at least one time before I do these with you all. And what that also means, I'm trying to write down my notes, things that I find that are really important for me to highlight, things that might have gone wrong when I tried it. Okay. And that's what you want to do too. So you want to bring your lab notebook with you and write in there what you're doing. So today you should have already written down your topic. The topic is diving ketchup. Diving ketchup. And I'll write that word down in case you don't know how to spell it. And ketchup has multiple spellings depending on the company that's trying to sell it to you. But I'll write it down this way. So diving ketchup. When I was younger, I used to see this other spelling more commonly, and now this one seems to be the predominant spelling. All right, diving ketchup. Diving ketchup. I used to see ketchup spelled C-A-T-S-U-P, catsup. But I don't really see that one as much anymore. I see this version of the spelling more commonly now. All right, so diving ketchup. And what are we going to do? By the way, if you've written down the topic, you should have also written down, as I was explaining, the things that you'll be using to execute this experiment. You should also consider we're using water in a bottle and a ketchup packet. So with respect to safety, what do you think I need to wear in order to be safe? Do I need any of the personal protective equipment that I explained earlier? The answer is no, I don't need it for this experiment. We are using water in a bottle. The bottle could tip over, so you have a bit of a spill hazard. And of course, you don't want that to happen near your computers or your phones. So make sure that you're doing it at a safe distance from electronic devices. But for the most part, this experiment is incredibly safe. Okay, so yesterday we took a flame, we lit a candle, and we had it in a plate. And in that plate, there was water. I dyed my water red, if you recall. And then I took a glass cup or a glass and I placed it over the top of the flame. You remember what happened to the flame when I did that? That is correct. It actually died or went out after a few seconds, right? Then after the flame goes out, all that water that was at the bottom rushes into the inside of the cup or the glass. Do you remember why that happened? Do you remember why that occurred? All right. It occurred because there was an imbalance or a difference in the pressure on the inside and the pressure on the outside. All right. Inside the glass, there was low pressure. On the outside of the glass, there was high pressure. And this occurred because the flame was heating up the molecules. When those molecules heated up really rapidly, the flame goes out and then the molecules start cooling down very fast. And you may recall yesterday I said that pressure and temperature are in a direct relationship, meaning if the temperature goes down, the pressure is going to go down. So those molecules that were super hot, when that flame goes out, they cool down really fast. That meant the pressure goes down really fast, meaning on the inside of the glass, we have low pressure, outside high pressure. That high pressure on the outside forces water into the glass. Well, today we're going to deal with pressure once again. All right, so following up on yesterday's lesson, talking about pressure and temperature, today we're going to isolate and just focus in on pressure. So, what do you think about when you think about pressure? What comes to mind when I say high pressure or low pressure? All right. Now, we made a cloud in a jar. I can't remember, I think it was 2 Fridays ago. And when we did that, I discussed with you weather patterns and how pressure has an effect on the weather. Okay, high pressure and low pressure. And that is a common area to consider when we talk about pressure. But another place we talk about pressure is in water. So there are people, we call them scuba divers. They're wearing this, I think, let's see, self-contained underwater breathing apparatus. That's what scuba stands for. All right, so they have the scuba gear on, and they have these tanks and like goggles, and everything's self-contained so they can breathe. The human body can only go so far underwater in the water because there's a lot of pressure that builds up the farther down you go in the water. You have a lot of water sitting on top of you, and then there's some forces in the water as well that you'll encounter deeper down that you wouldn't experience on the surface. And so the pressure increases. All right. We're going to today watch the effect of pressure on a ketchup packet inside some water that I'll place in this bottle. All right, so we can go ahead and get started. The first thing you'll need to do is, with your empty bottle, fill your bottle all the way to the top. I mean, all the way to the top. So you want to fill it all the way to this point here. All right, you're going to follow that up by placing the ketchup packet inside of the water. Now, when that happens, some of the water will spill out. That's fine. Just a little bit will spill out. But that is what you'll be doing. And then we'll go from there. So pardon me as I go fill this container up with some water. I will be right back. Okay, so I have now my bottle is full with water. It's water like all the way here to the top. Okay, now what I'm gonna do is I'm gonna introduce this ketchup packet to the bottle. All right, so ideally your ketchup pack, in fact, for this to work properly, make sure that your ketchup pack doesn't have any holes or rips or tears in it. It needs to be sealed, okay? All right, so again, you saw some water spilled out of there. And I'll have to get something to pick that up with, but let me go get something. Little towel here. Water everywhere. Okay. Now, recall I said you need your cap, and this is interesting. Okay. So it looks like my ketchup packet. Notice my ketchup packet sunk all the way to the bottom. That is a bit of a problem. That suggests to me that there might be a hole in my ketchup packet. So what I'm going to do is I'm going to take a second ketchup packet, and hopefully this one doesn't have a hole in it. It should float to the top. If it doesn't float to the top, then you may have a problem. So let me put a second ketchup pack in here. There we go. That one's floated to the top. Okay, good. So first thing to note or perhaps not the first thing, but something else to write in your notebook. The ketchup packet should float in the water. If it does not float, that suggests that the packet has a hole in it. All right. And we need, again, as I mentioned, for your packet to not have any holes in it. All right. Love doing experiments live. When you do them live, you never know what's going to happen. So that did not happen earlier. So I have a ketchup packet in here that is up at the top. I have one at the bottom too, so it will be interesting to see what occurs. But I need to now close this cap as tightly as possible. So I'm going to close this cap as tightly as possible. It's a little harder now because it's wet. All right. Okay. Now, here's the fun. I'm going to squeeze this bottle and watch what happens. Did you see that? I'll do it again. Ooh. You see that? So, and I have two ketchup packets in there. One's clearly got a hole in it. The other one is doing exactly what I expected it to do. So, here is your question. Why, when I squeeze the bottle, why does this ketchup pack that's here at the top, why does it go down to the bottom? All right. While you're writing your answer down, I'm going to check to make sure my folks on Instagram can see. All righty. So what do you think happened? All I did was I filled this bottle all the way to the top with water. I put a ketchup pack in there. I closed the cap, and then the ketchup went straight to the top. At least the packet that apparently has no holes in it went straight to the top. This other packet must have some kind of small tear or rip in it. But the packet that's sitting at the top, all I have to do is squeeze a little bit here, and it sinks to the bottom. Why is that happening? You'll notice even the packet down at the bottom, which probably has a small tear in it, notice that even when I squeeze, that one even goes further down, all right? It goes like all the way to the bottom. Well, what is happening is by squeezing the bottle, I am creating pressure. I'm putting pressure on the ketchup packet inside. Now, the reason, and perhaps I should have asked this question first, why does the ketchup float to the top in the first place? All right, have you considered that? Why is the ketchup floating to the top? What would make the ketchup packet go to the top? All right, what will make it go to the top is there's an air bubble in your ketchup packet. It's a really tiny air bubble. If you have like one of those packets of honey that you get when you get with biscuits at Popeyes, you can actually see inside of it, or like maybe a Lee's Famous Recipe chicken or KFC, they have those honey packs. You can actually see that there's honey in there, but there's also an air bubble in there. So that would be a good one to use as well. So that air bubble on the inside of the packet causes the packet to float to the top. When I squeeze the bottle, I'm creating enough pressure that that little bubble of air on the inside of the packet is affected. The air inside the ketchup packet is now being compressed. That compressed bubble of air is now more dense. It has a greater density than it did before. Because it has a greater density, the ketchup packet, instead of floating, comes down, all right, as I squeeze it. All right. So the difference is I've created pressure. That pressure has created a greater density within the ketchup packet, the air bubble of that ketchup packet. And therefore, when it has a greater density, and you may recall from our density tower demonstration a week ago, that the greater the density, the heavier or the further down the material will go. All right. So watch this. I can actually cause that ketchup packet to stay in the center of the bottle if I apply just the right amount of force. You see that? All right, so that could be kind of fun too. In fact, you could probably, um, you and a sibling or one of your parents can get a separate bottle, put a ketchup pack in there, and see who can balance the ketchup bottle, the ketchup packet inside the best. Right? I've got a lot of practice, so look at this. I can get this ketchup packet to float right there in the center and just keep it there. All right. As soon as I let go, it goes back to the top. All right, so let's recap. Why does the ketchup packet float to the top? Why does the ketchup packet float to the top of the bottle? Why is that happening? All right, that happens because there's an air bubble inside the ketchup packet that causes the packet to float in water. It's an air bubble, wants to go to the top. All right. What happens when I squeeze? That's right, the ketchup packet goes down. Okay, next question. Why does the packet go down? The packet goes down because I have compressed the air. I'll spell that word compressed for you. All right, so I have compressed the air. You can see that word compressed, pardon my handwriting. Compressed the air inside the packet, making that air bubble inside the ketchup packet more dense or greater in density, causing the packet to go down. Okay? All right, that is all I have for today. I hope you learned from this, and you can have a lot of fun with this. I may leave this here and play with it for a little while. So definitely give it a try. Oh, I did want to show you something. I did want to show you something just briefly. Let me just say before I show you what I'm going to show you, which is kind of messy, that if you want to see all the experiments from the first 4 weeks, they are posted to my YouTube channel. You can find my YouTube channel by going to youtube.com/C/Dr. Boyd the Chemist, or you can just go to YouTube and search for Dr. Boyd the Chemist. I will come up. Definitely subscribe. I will post all the lessons from this week next Monday morning. I also have lots of videos on there that I have posted for the past 3 years. So you can definitely check that out. Several dozen videos there. I did want to show you something. Last week, Monday, you may recall, we took an egg and made it rubbery. And I said the reason that the egg becomes rubbery is because it is taking in water from the vinegar. I placed it in overnight. You may recall that I did that, and it made it large. I did the opposite thing. After I made the egg really large and rubbery, I put it in corn syrup. And corn syrup is very sticky, so I'll show it to you what happened. The logic was that if I can make the egg expand by having water go into it, I should be able to make the egg shrink by having water come out of it. And recall that the process of osmosis means that you're going from an area of high concentration of water through a semi-permeable membrane into an area of low concentration of water. In this case, now I had this rubber egg that was really large and full of water. If I stuck it in a solution or a liquid that had a little water in it, the water on the inside of that egg, that large rubber egg, should want to come out into this area where there's less water. Look what happened. This is really messy. Look what happened to my egg. It like deflated. All right, I'm gonna play with this just a little bit. Only with one hand though, so I can turn this off when this live stream's over. Look at this. Ah, look at this. You can see the semi-permeable membrane, right? This is the sac around the egg. Isn't that crazy? And you can see the yolk is like rock hard on the center, in the center there. All right. Pretty cool. So I'm going to play with this some more. I'm actually going to put it in either vinegar again or in water to see if I can get it to re-expand, because the logic should hold. Now there's like very little water on the inside of here. If I stick it in something like water or vinegar, the water or vinegar should want to rush into the sac. All right. So I just wanted to show you that because I was still playing around. I'll probably shoot a video explaining all the science behind what I did there and with cool visuals. With that, I am done for today. I'll see you tomorrow, 2 p.m. Eastern time. I'll be doing this at least through the end of this week, and I'll keep doing these as long as I can. And once I'm finished, again, everything is posted onto my YouTube channel. Don't forget to follow me on Instagram at science made simple _LLC, and I will see you tomorrow.